Okay, I frequently field questions about coronavirus and how it all works. So, let's say coronavirus, and we all know it kind of looks like that. And you can catch it both in the air, if it's been recently coughed, sneezed, whatever, or by touching a surface. So, and here, let's do this one. So let's say, we'll do a head. We'll do a nose. And we'll do our eye. Anyway, it works. So let's say you inhale it in your mouth or your nose and it comes down. Now it can affect you just in your nasal sinus, and that can be its point of entry. But very commonly, let's go down now to where your lungs are. And obviously it's not to scale. Okay, so one lung, left lung. So it comes down, and obviously they're teensy tiny. And it is in contact with your surface cells. Well, viruses like this have a way of fooling our body, and your normal cell, let's say, looks like that, and it has little receptors and such on it. And if this virus comes into contact, it can be taken up by the cell. And that's just one of the tricks of the virus. And it also then starts to replicate or reproduce itself inside of that cell. So you can have one virus particle that is inhaled, though it usually takes a ton more, and it gets into a cell and it can make a bazillion copies of itself. And then it is released into your body. And now you've got, and here I'll leave the little dots off of it, a bunch of them. So now these are all floating through the body, and here we will be specific. So now you have COVID-19. Well, we have certain cells in the body that sense foreign materials, substances, viruses, bacterias, whatever. Well, bacteria. And these will come and take hold of the, in this case, virus, and attach. And it is an antigen, so this is considered an antigen because you're going to hear about that, which is the outside whatever it is, antigen. So your body is going to have an antigen presenting cell. And it takes it to other areas of the body where we can actually start to mount a defense against it. Now, usually we have a ton of cells that have all taken up parts of the virus or different virus particles. And so you have a huge number of these that are being put out into the body. One of the ways that we test for COVID is actually to look for this antigen. So it's in the stage where it has infected your cells, it has reproduced itself a ton, and that's when they do a swab up your nose and down your throat. Not super fun at all. And they do a special test, and it will amplify even more this particle or this virus. And it does the RNA, I believe, in this case. So then there's a test that will quantify how much of this is here, if it is here. So when they're doing the tests right now that are taking 1, 2, 5, 7 days, this is the test they're doing. They are actually looking for the presence of COVID-19 virus itself. Now, there are other ways to test for that as well. Now, this is obviously only going to be a positive test if there's a ton of virus in your system. So in the very beginning, the first few days could be 4, 5, 6, 7 days into it, because your body finally figures it out, and the antigen presenting cell will take it back to 2 different kinds of cells. We have a T cell and a B cell. And these help us fight things off, mount a response, do whatever our body needs to do to get rid of it. So it takes a little bit of time for both the virus to build up, for our body to sense that something's wrong, and for it to take it back to our cells that are going to help us fight it off. So part of the problem and part of the reason that we get such a big response from COVID, especially in the lungs, is when the antigen presenting cell actually shows it to the T cell, the T cell in response releases a ton of cytokines, which cause a huge inflammatory response, which brings blood flow and a bunch of other cells to the area, and in this case, the lungs and the airway in general, to help discover what's going on and determine what else is needed, how do we clean it up. But this on its own with the inflammation does cause a problem for us, and it causes our lung lining to get thickened and inflamed and very irritable. It's kind of like an asthma-like reaction where you can't get enough air in. There's not enough air that's actually, or oxygen rather, that's actually getting through the lung tissue so it can be absorbed by the body. And this causes us to feel short of breath. Now, while it's a defense mechanism, while it's defending, it can cause a lot of symptoms. Now, the other cell that the antigen presenting cell will present to is a B cell. The B cell actually produces antibodies. So antibodies, and sorry, this one's not working, are very specific. So the B cell senses specifically this molecule, this virus, and when it produces its antibody, it is specific to that molecule. So it releases a ton of these, and it can float through the body and fight it off. It will attach. So let's say we have one coming down here, and we have an antibody that will attach to our virus. And then our body knows when this antibody is attached that this is a cell that is dangerous and it needs to be cleared from the body. So, the other test that we can do for COVID-19 is an antibody test. So, it is actually looking for the presence of the antibody, meaning your B cell has already been shown this virus. It has a specific defense molecule, which is the immunoglobulin or antibody that will fight against it. And so the more virus there is there, the more times it's shown to the B cell, the more antibodies it makes. In the beginning, when you first have an infection, the type of antibody that is released is an IgM. That's an immediate antibody. Something's going on right now, or it was going on recently. That's the other test that you can do. So it will check for that specifically. So what it means is maybe I can't isolate the actual virus right now using this test because our body's already fighting it off and there's not enough copies. But our body has mounted a response against it, which means it has seen it, it has fought it off. So you can test that way. And that says, yes, I did have the infection. I was exposed to it. My body fought it off, whether or not I knew it and had symptoms. This test will stay positive for about 6 months. After that, these cells start to kind of forget. And the other cells that take over are called IgG. So IgM starts to wane, and these cells are no longer produced or present after about 6 months. At that point, IgG antibody continues on in the body as a long-term memory. So if you had an infection greater than 6 months ago, if it was 6 months, 6 years, 60 years, typically your IgG that's specific for this molecule will still be present in your body. And you can test for this as well. So there are actually then 3 tests that you can do right now. One is looking for the antigen. Number 2 is looking for IgM antibody, and the third type is IgG antibody. So hopefully that helps. It still gets confusing, but there it is.